To start our day, we've got a good friend of the Cloud Village speaking, Jenko Huang. Jenko is a principal researcher on Netscope's threat research team, focusing on cloud threats and identity abuse. In this talk, Jenko is going to cover research and tooling to improve cloud defenses in AWS, Azure, and GCP, using more stealthy measures which complement existing techniques. The title of the talk is Cloud Tripwires, Fighting Stealth with Stealth. Everyone, please give a warm welcome to Jenko.
Thank you, Mike, and thank you everyone for coming Sunday morning. You look as tired as I feel, so thanks. Hope your con is going well. So as you might gather from the title, I'm talking about something a little less common, maybe a little less popular. Defense. Yeah, I've got my blue hat on. That's right. So we spend so much energy, and it's good energy, at DEF CON talking about research on the attack side, the red side. And ultimately that helps us in the security community improve things, right? The vendors are a little bit slower than we'd like, but they ultimately do listen. So I'd like to sort of switch our brain power, if you're willing, to the defense side, because I don't think we spend nearly as much time there, and we really need it. So I'm gonna go through a few things. And I'm going to start with a demo, which I translated to screenshots just because of time constraints. And it's about a technique that is several years old. And if you're into Azure and Microsoft and you don't know about Dr. Azure AD and Dr. Cinema, he's awesome. You should follow him. A lot of research has spawned off of that. His blog is sort of down because he's joined Microsoft from SecureWorks. But this is sort of an ode to something he published 3.5 years ago, which is Microsoft's device code flow implementation being highly susceptible to phishing, as well as carry on lateral movement and privilege escalation. So I've got screenshots from a demo, and I'll talk you through it, right? And I basically want to point out how advanced and moving the research is. And even if it's 3.5 years old, this is highly relevant. Not enough time is spent on this. So on the left, imagine you have a regular Microsoft user logging in, right? This is one of my throwaway accounts. And it actually has MFA on it. It's actually a global admin in Azure. It is cached, so I don't go through the MFA process, but normally I would. And I pop into Outlook, so nothing surprising there. On the right is the attacker executing device code flow in OAuth. Now, you may have to look at the slides to actually see it. I'll talk through the important points. Device code flow is really easy to execute. This is payload of invoke REST method in PowerShell, which is as close to, raw curl with post get that you can get. There are two attributes supplied to kick this off as an attacker, right? A valid application obviously would do the same. One is the resource, which in Microsoft land is the API being requested, Graph API. The client ID in OAuth terms is the application client ID. When you as a developer of an OAuth app register it in your tenant, you get a unique ID. I have two things. These are sit in a loop querying Microsoft saying, as soon as that user logs in, give me the OAuth tokens, as soon as they approve. So popping on the left is the phishing email. I want you to just appreciate my HTML capabilities. So this is an Office 365 phish for extra storage. Promo code, which is the user code I got as an attacker from Microsoft, from the device code flow. That's the official Microsoft device code login. There's nothing funny there. This is exactly what you would see in any device code phish. So if the user follows it, they pop in the code I sent. They go through normal login. It's cached, but again, normally this would be an MFA login, right? So one of the things we'll get is bypass of MFA. We're going to have the user put in their one-time code. We don't have to intercept it. We don't have to do whatever. It's one technique to bypass MFA. I want you to focus on this end game. This is all the user sees. Are you trying to sign into Microsoft Office? Why does that text appear? Because I use the client ID. If I'd used my own ID, some app I created, I pick a name when I develop it and register it. And I can't choose Microsoft Office. They prevent you from doing common derivatives of their own products. But I chose their app ID, so great. This looks all official to the user, right? No reason not to trust it once you get to this process. The domain is Microsoft, nothing funny there, right? What does the attacker see? So finally, after you set next on the left, you just get a simple confirmation, good, you're done. What's the attacker see? Well, they return from that polling call and they get an OAuth token right there on the bottom, access token. They also get scopes, which is part of OAuth. I want to point out that at no point to this up till now did the attacker have to specify scopes. In normal OAuth world, you specify scopes as an application. You're going to ask the user for their permissions for the such and such. These are directory scopes, Graph API scopes. Microsoft decided to implement default scopes. That's stupid. That's not really common or part of OAuth, but they did it. I also get a refresh token, which is part of OAuth. The dirty secret is everyone says temporary token systems are more secure because they're temporary, yet we have a refresh token that for all intents and purposes is permanent. Yes, you can revoke it on the user side, but if you don't, if you use it like every 4 months, it just stays fresh and you will have permanent access because of course, third-party apps like your email client or something needs to continue to get email without having you re-log in. Back on the user side, they do have an Azure account. They happen to be global admin. Here's some resources. What the attacker's going to do with this Graph API token is, of course, do Graph API calls. They will get the users out of AD because that's a Microsoft thing. You can enumerate users very easily. They will get email as well, another Graph API piece. Now, here's the kicker with this technique. Microsoft implemented a really bad thing. In OAuth land, you don't get to switch your permissions once you have a token without going back to the user to ask them for new permissions. This case, the attacker faking or impersonating Outlook asked for Graph API and whatever scopes there were. Now, they're going to use the refresh token because Microsoft allows them to get a token, a new token with Azure access, which is what's highlighted there. That breaks the OAuth model, and there's a reason why Microsoft did that besides being stupid. It's for SSO reasons. They want they're using OAuth for SSO, which is also stupid. Don't use authorization protocols for authentication, but they did it. So, because as an attacker, they're continuing on their flow, they've got a new token, it's Azure Management API enabled, they can now enumerate all resources. Okay, it's the user's permissions. In this case, it's global admin, so it's everything. Okay, great. We just went through this flow as a user and attacker. It's fairly complicated, but I want to point out that normally, if this weren't an attack, there's a step 1, which is a user installs an app, and then they're expecting all of this prompting. Well, we convert it to a phish. The attacker starts with step 2. They're fully in control. And again, the client ID is not even something they had to create that traces back to them in the logs. It is Microsoft Office client ID. The other piece at the tail end was we switched permissions and did a lateral move, which you could also call privilege escalation, by trading our token, refreshing, and getting Azure management resource permissions. From a logging perspective, when you look at the logs, when the attacker script actually gets the first token, that is logged, yay. When they refresh and pivot to Azure, it is not logged. You might guess that developers didn't want to busy up the logs with a refresh, which might have to happen like every hour. Who knows why? It's dumb, because you're not seeing the lateral movement. The details of the actual log are what you get in the sign-in logs. It's not bad. It means you have a chance to mitigate this with conditional access policies. That is the recommended way to do it. Conditional access policies are a bit of a Swiss cheese thing. They are imperfect. If you do research, you'll find that there are ways still to bypass it. Knowing this, Microsoft didn't stand still. They added device code as an attribute. You can put that in conditional access policies. You can prevent all apps from using device code. That's not a bad idea, other than the fact that Azure CLI uses device code. So you're going to have to be creative to actually get the right policy. Second, there's an enumeration, a static list that they keep adding to of apps. Microsoft Office, the actual app ID I picked, is not in that list. It just means fine-grained control of conditional access policies. With this app that I impersonated, is still very, very tricky to get right, even if you know all of this. So there we have it, a 3.5-year-old attack that is still popular, not well educated. So when we look at the big picture, let's just go to Microsoft, since we're bashing them a bit, and look at their unfortunate incidents. So we have Blizzard from March. Our favorite nation state, maybe along with China, Russian hackers. I'm sure you all have reviewed it. Some techniques are old, like password spraying, exchange or email as a target, proxies with a little twist of residential, and then OAuth apps, coming more and more common if you've been reading the news. In there, maintain access, persistence, elevated access, privilege escalation, being a little clever, using a legacy app to create a new user account and then bless another app, right? Leave your, little creativity. Let's switch to Storm last summer. Let's switch nation state actors to China. Now we're going through a common attack vector of email again. But it's more complicated because underneath we have MSA tokens from the consumer side of email, and somehow there's a bug that allows that to sort of switch over to corporate email. At the end, I'm not here to say Microsoft's bad. They've got smart people. They've got legacy code and a big install base. Defense is hard. When you look through Storm's techniques, anyone who's read, and I applaud Microsoft for disclosing their process, but if you read it closely, Microsoft got confused in their own analysis. They'd be like, oh, we think it's a race condition and we think there's a crash dump, but we don't actually have that evidence. But it seems out of code review, it seems very, very plausible. So steps 1, 2, 3, 4, 5, it looks like a perfect storm that allowed this to, pun I guess intended, to actually happen. Obviously a very sophisticated APT level nation state actor, but the point is defense is hard even for the best who have money and expertise. All this to say, before we talk about defense, the question is, why do we even have to talk about new defense? Because attackers are winning and we know which side of the field they're on, right? And it's not just buzzwords and headlines, which is easy to paint a story. What I appreciate about DEF CON is you meet some of the greatest researchers sharing their work. And here's just a smattering from the last couple years that I've just jotted down and are somewhat related to things I think about. Every year there's another 20 of these. So enumeration without logging. I think Nick Fourchette, big fan of his. He spoke last year, he spoke at Black Hat, he's speaking after me. AWS, enumeration without logging and other sophisticated techniques. Obviously we know about Rhinolabs. There's classic techniques, those still sitting around, to enumerate SharePoint URLs without authentication, right? Enumeration is tough to stop, even if the vendor plugs a hole. There's access and persistence in unmanaged, or at least less commonly thought of, full-blown virtual machine environments. Guess what? Cloud Shell runs in a VM. Guess what? The protections there are pretty low. Guess what? They want to push it for free to everyone because it's really easy. Pre-configured environment with a CLI set up and full access. So open ports have been spoken about by my colleague Hubert Lin at this DEF CON of how you can abuse that to get access to a whole bunch of services. We just went over number 3. A couple years ago, Matthew Bryant, server-side scripting in Google Apps. I didn't know that existed until he talked about that, with loose permissioning, right? As if Microsoft didn't tell the world and Adobe that embedding scripting code in documents was a bad idea. Google had to go copy them and say, no, we're going to put it in the server, an ability to open a doc and execute code. What could go wrong, right? 5, service principles at this DEF CON. I loved Cloud Village talks. There were at least 3, 4 people that I listed that were diving into Azure service principals, managed identities, enterprise apps, app registrations, cross-tenant access, and the admin roles. And there is so much there to mine. We're just scratching the surface of abuse there, right? It's being talked about a lot more, and a lot more is coming from that. And then Asterisk a couple years ago had a GCP attack where they used the temporary deletion of a project for 30 days to hide stuff, because once you deleted it, it disappeared from APIs and portal views, and in there was an OAuth app. So it's a persistence move. You need access, set it up, you undelete the project, you use the app for whatever, privilege escalation, you delete it again, just make sure you come back in 30 days. And so as I'm working this year's CTF a little bit, creating a challenge, Azure has a similar temporary delete status folder for Azure objects, including service principals, right? So ability to hide code and privilege really easily, right? So this is just off the top of my head. The point is attackers are winning, they're smart. Even our research shows that, right? Our greatest minds. So it can feel like you're going to a gunfight, but the attacker's the one who has the gun, and you're walking uphill. They changed the rules. The asymmetry, and what I mean by that is every dollar and every hour they spend causes like an order of magnitude on the defensive side. They have stealth almost by the get-go and default. They take advantage of every single ability to execute code within our blue hat environments. That is like VMs, the obvious one, then there's serverless functions, then those things hiding as VMs like Cloud Shell, or as I think Nick Fourchette pointed out, VPC endpoints in AWS are just running on some kind of VM. OAuth apps, which is code and privileges, and app scripting in Google, among other things, with a ton of backdoors. This ghost token, these OAuth apps, this code. And then, of course, they can attack the human layer, which we know is the weak link, right? All of this, while the defensive reality is you feel like you're fighting with a butter knife, okay? And unfortunately, here's where I think security, we've fallen into a rut. We don't challenge ourselves. I think security is too much done by checklist. You think about it. What's a good best practice by a vendor? It's a checklist of usually configuration, sometimes some detection, sometimes some remediation. So you feel good if that's your job, you're done with the list. Your boss is good, compliance will pass you. Are you really secure? We all know better. You have to actually think about it. But we don't really think about the design issues, the software issues, the things that are causing havoc, like the demo screenshots. Is OAuth really designed well in Microsoft? The answer is no. So that should cause you a different stance rather than, here's the best practice for securing Microsoft OAuth. Put in a conditional access policy and be done with it. No, you're still exposed. Do you know that, right? Staying behind the moat is this idea that it's great, we paint these analogies, that moat is our outer perimeter, then we hide behind it with a good drawbridge, we throw some alligators in the moat, we go with a high wall, put some archers on top. Okay, do that, but how about send some peasant spies out into the barbarian lands and do something a little more proactive? Because that's what the red team's doing, that's what the attackers are doing, that's what social engineering's doing, right? Why don't we borrow and apply the same brain power on the blue side? Now, defense in depth leads to layered defenses, which is great. The problem is the implementation at the human level, I think, leads to isolation. My firewall team doesn't talk to the IPS team, which definitely doesn't talk to the malware team, much less my machine learning risk analysis SIM team. So we've broken the problem into three, discrete components. The attacker's like, you're a fool. I'll social engineer the network guy through the help desk. I'll pivot and I'll get app credentials and blah, blah, blah. And we have groups not talking to each other. The threat and attack vector and attack chain cuts across everything, but we're organized in layers that don't talk to each other. What's an example of that? Here's a minor one, which could be a major one. shows itself in product features. Google Cloud has a timeout, a session timeout for your cloud logins through the portal, as well as the tokens you might get. Good idea. Default sucks, but it's a good idea. Where is that located in API land or the portal? In Google Workspace. I get we have a common identity service, but that might be two separate groups in a large organization who don't talk to each other. Imagine an incident happens and you have to revoke access and force a revocation. Are you trusting the guy on the Google Cloud side to know where to go to set the timeout? Of course it's not going to happen, but this is the world we have fallen into. Defenses are static, they don't change much. Same for all attackers and all environments. They tend to be pretty generic, not completely, but we tend to be like, let's go through the checklist, we're done, let's move on, and everything's in plain sight. So, what could the future be? My whole premise is think more about design and less about checklists. Go towards the attacker. Yes, think in their mind and be in their shoes, but get closer to them. Do recon. Figure out how that fits. Cut across your organizational boundaries. If we're going to do stuff, we got to start with engineering teams within organizations. They're developing crap and sending it through DevOps, right? Insecure apps are going to cause havoc on the ops side. And then you get to threat hunting and risk assessment. Everyone's got to be working together. Now, I get this is stuff that we may not be able to control, but the advantage is I'm not trying to create a product. I'm trying to burn everything to the ground and rethink how would we do this better? And we would definitely address some of these. We would be dynamic and changing and make things stealthy. To the extent that it doesn't screw us up, we would be changing things so attackers, the analogy would be change the bank vault code every day, because if you get an ex-employee or a paid insider, it makes it harder for the thieves to break into your vault. Not perfect, I would rotate the key. Instead, we tend to be static, right? And all of this is about tailoring things by CSP, because every CSP is different. AWS is different, obviously, than every other one. We would also tailor it to the attacker techniques. To the extent I can intuit attackers shifting their techniques in a fundamental way, I have to change and create new defenses. We do some of that. It tends to just be reactive. Come to DEF CON, wait for someone to publish something. Oh, there's a CVE, I mitigated it, move on. I think we need to think more fundamentally. I think in the coming year will be a whole bunch of service principal attacks and related ones on Azure, because that's the gold mine. It's complex and it's a way to escalate privileges. Let's get ahead of the curve, think about that design, put in defenses. Okay, enough of that. That's really high level, I get it. Let me tell you a story to try to make this real. It's an old school story. Unix. This was before Linus ate the world, so Solaris was still around. It was probably 20 years ago. The idea is if you have an inner sanctum kind of server, super important data. Maybe it's, Hunter Biden's real laptop. Maybe it's the Zelensky audio that got hidden, or the video of Trump in Russia, whatever it is. You put in protection, right? Layer defenses, but you gotta be thinking, what if someone breaches the ring 0? What am I gonna do? How do I detect? And then how do I do, it's not really remediation, it's just save the jewels. How do I, pull the plug, take it offline? So, you think about, it's likely they'll be on a shell. Even if they have the sophisticated RCE, usually at some point the attacker's gonna get shell. Then you think about, this is a story told by a really good CTO boss of mine. Then you think about the attacker, what they might do. Well, they're likely going to do LS in the first 2 commands, right? And then you switch it up on the attacker. So instead of the real LS, you make it execute shutdown now in some form. Now you might not do this crappy little shell script, but you get the idea if you can read jokes in Unix, right? And bash or shell. The idea is you fool the attacker so that it not only detects it, it fixes the problem. Yes, it shuts it down. Someone has to probably physically or remote get into it, but you save the crown jewels. Now, that's all well and good, but you do have to use this, right? It's not just a fake trap. So what do the good guys do? They train themselves. Now, I know this is a little hard, but this was the true story. They learned how to do echo star and shell expansion as their poor man's ls. So for Unix guys, that's the story, true story. But what it represents is this idea of tripwires and this whole point. Can you identify choke points that are likely to be traversed by the bad guys? Can you create a tripwire that is stealthy, that they will trip themselves? 3, can you create a grenade, and it could be something a little less than a grenade, like a video logging, whatever, alert. But you get the idea, something for an action, but don't kill the good guys and don't confuse yourself. So in Unix land 20 years ago, this was an anecdote, but it sat in my mind for 20 years of how can we do this in the cloud. So I think I got about 5 minutes, so I'm going to have to get into the good stuff really quickly. You guys got to keep up. All right, there are some common techniques that I think we can incorporate in detection. The trouble with trying to stop an individual technique, as you've seen, is they're very sophisticated, they change. You stop Nick Fourchette's cool, awesome enumeration technique, he's got another one, I guarantee it, next year. He's that good if you've been following him. It doesn't think about, China, APT0, we got smart guys. So instead, I wanted to look at choke points. What do attackers, pen testers, and you guys feel free to disagree, think about it. What do you do once you get initial access? Even after you get privilege escalation, you often do more recon because you don't want to leave money on the table. You could. I'm not trying to solve every case, but when you do discovery, you might, to take an AWS example, enumerate resources or security principles, right? What buckets are there? Do a list on buckets. And then go probe, right? You might be worried about being detected and think about what's in CloudTrail or not, but some of this is in CloudTrail, and you're just gonna be like, let me go slam into the Apple store, grab the stuff, I'll be out of here. By the time they come, doesn't matter, right? Of course you will. What else might you do? You might check your own permissions. List your IAM policies or equivalent, because that'll tell you what the admins granted that user. And there might be explicit listings of an AWS LAN generic sort of policy of, oh, I can do things like assume role. That's interesting, privilege escalation on, such and such service. I can get and list this bucket called finance, right? So on and so forth. I might have wildcards. I've got stuff to work with. Directly try or do a little bit more discovery. So what's my premise? This is pretty common. Enumeration, resource access, security principal access. Back to tripwires. I'm going to set up some fake ones. Very enticing ones that are highly monitored, that are unlikely to be used by my good users or valid users. Simple enough concept, hard to implement without false positives, but it can be done. And my point is, if we don't start the hard thinking now, we'll just be in checklist security forever, which is good job security for everyone in the room, but not great for society at large. So what do I mean by that? I might allow financeacme.com, of course, to be a fake bucket, among others that they can enumerate. The real finance one isn't accessible, or it's named something else. It's just one method among dozens I want to bring to even that playing field. If they assume role, I can see what roles this user is allowed to list. There might be the default admin. And so I might want to be smart about setting up fake roles that are real, but maybe with stunted permissions. And in explaining that, I want to point to tools. I want to be smart about tools. So let's take pacu. And it has a dictionary list of roles that it will use, a very nice, sophisticated technique to check if it can assume it. And it's not logged. Well, if this is a popular tool, I'm not just going to get the benefit as a red teamer. I'm going to set up some fake ones based on this. Yes, admin I can get to on my own, but how about I don't know why they have Aaron in there, but API gateway in AWS. I don't use this in my org. I'm going to set up some fake ones with restricted permissions, monitor the hell out of it, and my valid users shouldn't be running pacu internally. And so I'm thinking ahead, maybe this gives me low false positives. Someone who hits a account or Abram, as an example, might be a high true positive detection that I can act on, and it's just a tripwire that I've set up. Be tool specific. It's dumb. Why would I set up defenses ignoring all the tools? So the dictionary lists are a big one. Let's shift gears to compute, which is highly open-ended. This brings us into the old world, the fully open ports, run any code, it's a nightmare, right? But of course it has to be provided. Netflix security team does awesome work, and this is years old. And of course they have the resources, the know-how to implement this, so it's sort of guidance with a little bit of code. They took the normal process. This is, right, a big attack vector, grab the credentials of the EC2 instance if you can get on it, or hit the metadata service, right? So normally, application will hit that locally on the server and grab credentials and have it returned to them. But what Netflix did is said, I want to IP restrict that credential. So if it's used off board, I detect it, or it won't work, or I can monitor it. So instead, they did some sophisticated things. They set up their own proxy, reworked iptables, so any request to the metadata service hit their proxy right there in white. At boot up time, that proxy got the IP address of the EC2 instance it did. They did something really clever. They assumed role, they set it up so they could assume the role of the EC2 instance in step 3. They can wrap, when you do that, you can optionally set a policy when you assume a role and get those credentials back. So they've set an IP policy like this in red. And that IP is the EC2 instance. They effectively are getting temporary tokens that they created that are bound to the IP address. And they can do whatever they want with it. It can be a straight out deny, right? Very clever. Takes some work, very clever, and it's going to mitigate breaching and compromise of your EC2 instance. I want to take that idea and be a little more subtle. I may not want to stop it, I just may want to log it, right? I know my policies and procedures are to do certain things, never go off board, but if someone steals it, I might want to just record their IP address and do something else with it and not just outright block them, right? I'm thinking defense and detection. I might want to give them some phishing line, let them do it, or I might want to block them. My point is, we got to think about prevention in a new way. If you prevent something, I don't want you to drop that deny block on the floor. Think about firewalls. It gets really noisy on the perimeter. Denies usually are not logged. Because of that, they get dropped on the floor. They're also false positive land, like a Tor exit node. You get that on the firewall, what's the use of logging that? Are you going to really act on it? Better just to deny it and drop it. No, I want to change that. I want you to do the job, but I want to collect the information that I got traffic from China or a Tor exit node. And if I ever see that elsewhere in my environment, that helps me. My defenses internal to the moat get helped by perhaps defensive measures outside at the perimeter. Really, really nuanced view. Let me cover one last cache sort of external credential. I want to move forward towards the attackers. I don't want to sit behind my moat. So most of the external programs, including the CLIs, cache credentials. Most all of them put them in clear text. You ask the vendors and they're sort of like, well, yeah, if your endpoint's compromised, you're screwed. Sorry, good luck. You know, that's CrowdStrike's problem, not AWS's problem. I mean, right? That's what don't use static API keys. Oh, great, thanks. But I do need something. So in there, SQLite database, this is Google, everyone's the same. What I want to do from a detection perspective is put fake credentials in there. They actually work, are highly limited, they go to empty accounts, monitor the hell out of them. These survive updates, they're config. I can plant that one time on my admins who work from home or over whatever VPN, plant them. They'll probably stay live forever with the most tokens, the way that they work. If they're ever compromised and I detect that activity in an account, boom. Low chance of the admin using it. They'll be trained, but unless they're looking in their own config or listing configs, I want to think more like this, right? Choke points, tripwires, specific to the design of cloud providers. Grenades or actions have to be really thought about carefully. And don't killing the good guys is probably the key here, because even if you buy that there's ways to detect advanced attackers, the key is, how do you not screw yourself? Because you screw yourself, create work for yourself. If you're a blue hat, you're out of a job, your boss gets pissed, blah, blah, I get it. So, what do message of the days do in honeypots? They probably, in some way, disinvite or invite the bad guys or good guys, right? It says, hey, this is not allowed as a site. You really should log off the server, right? That's the message of the day in a honeypot. And the attacker ignores that, so when they do further activity, you have a higher probability. What's the example in S3 bucket? It's the top level file, because everyone's going to enumerate from the top. So yeah, a valid user might go there, but I've got a README that says, you know what, this is the old finance bucket, and it's only, authorized for finance personnel. If you're looking at it, you should really not look at it. 3 levels deep in the path, I have all the interesting finance files with further warnings of, hey, this is not really current. You should ask your administrator for access to the current one, but this is current as of a month ago. And if there's enumeration down that path ignoring the signs, then you have a higher probability. You add this into the mix to refine and lower your false positives, right? You take a simple access to a resource and you try to make it work for you. You restrict admin roles. What do I mean by that? It depends on CSP, but maybe you keep the real admin role, you create a custom role that has that privilege. That's what the valid users use. What do you do with the real admin role? You restrict it if the CSP allows you to do it. Take root, for example, in AWS, right? Common wisdom when you first get on AWS is root can do everything. Well, not actually. You can have a VPC, or you can have at the org level, you can have a boundary control, right, that you implement that can prevent root from doing things. So if there's a capability, you can stunt the default admin roles, use a copy or a custom role. Now you have a way to distinguish valid users, don't kill them, versus attackers who always go after the default admin roles. Doesn't work everywhere. You got to put your mind in design. So you keep doing these things. You also add in signing and tagging. Session tags in AWS, when you assume a role, you can basically pass along some tags. You could incorporate that into workflow. Valid users pass in the right ID. It doesn't prevent them from assuming role. It just identifies them as I know the current month's secret ID. Attacker wouldn't do that. They would get success. They would plow ahead. They're not stopped. They would plow ahead. They wouldn't bother backtracking, trying to figure out if an ID is being used. Okay, that's the AWS session role. Okay, I got to wrap this up so I don't cut too much. So this is my last slide. What's the practical of all this? If you've heard the theory and you think there's a chance of this approach, there's some requirements for this to even see the light of day. So I'm starting in the middle. There's got to be comprehensive research. That's my job and anyone who's interested. You got to look at everything to try to see where are the choke points across APIs, not just the CSPs, but the app APIs. They have to actually work and not kill the good guys, efficacy. The cost of using this has to be low enough because none of us are going to do a lot of work for little return on the blue side. And it has to sort of pass that open source kind of sniff test. If you're a Red Hat and you know this is in place, are you still slowed down so that it's a more of a level playing field? And the point I would say is, even if you know I have fake roles and resources in play, you don't know exactly which ones they are, and at a minimum you are slowed down when you enumerate, and before you assume a role, you have to think about whether that's real or not, and you likely can't a priori know that if I've set up the environment right. You have to try it, and when you try it, I'm counting on I've set things up to distinguish you from a good guy. So practically speaking, in the next coming weeks, I'll be publicizing some tool set as a POC, some software to sort of show how you can implement these do CRUD operations, report on them, delete them. The idea that you could have a CLI that helps you with creation of tripwires and not have it be a hassle, like wondering what the heck is in place, how do I delete it, did it actually work, and so on. But we have to keep publishing research, keep thinking about this, putting as much time and effort as we do on all the good stuff on the red side. So I think I'm over time, and I apologize. That's the end. Would love, if you have comments, even if that's the dumbest idea I've ever heard, love to hear it, because that just makes me work harder on this effort. It's a long-running research project, and it's just something of, we got to think different is the bottom line, and we've got to try it. And I'm convinced if we took the smart people at Con, we would make greater strides than just a tool of the day which fixes an issue of the day on a checklist. Those are important. I'm not saying don't do it. I'm saying what prevents us from doing the same damn thing every con with just a different list? Only if we're as creative and smart on the sort of long term with some implementation. Thank you.